Video, I'm going to talk about what types of functions are continuous. My name is Hossein Lameh Ramandi and the intensity of this video is mild. Let's recall some definitions and facts. Recall that a function f is continuous at c if the limit of f of x at point c is f of c. A function f is continuous on an interval I if it is continuous at every point of that interval. If I includes some endpoints, then only one side continuity at that endpoint suffices. By this fact, we can make new continuous functions from old continuous functions. Assume f and g are continuous functions, and r is some real number. Then the following functions are continuous. F plus g, which means that you can add up continuous functions and get a new continuous function. F minus g, which means that you can subtract continuous functions and get a new continuous function. F dot g, which means that you can multiply continuous functions and get a new continuous function. Rf, which means that the scalar multiplication of a real number and a continuous function f is going to be a continuous function. FOG, composition of two continuous functions, is a continuous function as long as range of g is a subset of domain of f, which means that the composition is defined. F over g, as long as g of x is non-zero, f over g is going to be a continuous function as well. So these are the operations that you can have on continuous functions and get a new continuous function. This is what I mean by making a new continuous function from old continuous functions. For instance, you can make polynomials and prove that polynomials are continuous functions. Because y equals x is a continuous function, you can have that, for instance, x to the 4 is a continuous function because you can multiply x 4 times by itself and get a new continuous function. Have a multiplication of 3 and x4, you can get 3 times x to the 4, then minus x plus 1, that's going to give you a continuous function. So all polynomials can be proved to be continuous by the same method. Rational functions are going to be continuous the same way as long as the denominator is non-zero. For instance, 3x to the 4 plus 1 over x2 minus 1 is going to be continuous at every point which is different from positive or negative 1. Okay, now we introduce more functions that you can combine and make new continuous functions. For instance, we already know that polynomials and rational functions are continuous. The root functions are continuous at every point of their domain. Trig functions are continuous at every point of their domain. Inverse trig functions are continuous at every point of their domain. And logarithmic functions are continuous at every point of their domain. So the important fact is that you can combine all of these functions together and make new continuous functions. What do I mean by combine, or by the word made in that quotation mark, is that we can use the operations here, which means addition, subtraction, multiplication, composition, and fraction, to functions here and get a new continuous function. I'll finish this video by this example. Where is the function f of x equals sine x plus natural log of x, natural log of square root of x minus 1 over x2 minus 4 continuous? So because as you see, f is made by some trig functions and logarithmic functions, root functions over some polynomial. So it means that it is continuous at every point of its domain. So let's find the domain of f. The first requirement is that x minus 1 has to be positive, so x has to be greater than 1. Also, x squared minus 4 has to be non-zero, so x is different from 2 and negative 2. So the domain of f is going to be the union of two intervals 1 and 2 union to positive infinity. So because the function is continuous on its domain, at every point of its domain, it means that the f is continuous on the interval 1 and 2, and it's continuous on the interval 2 and positive infinity.